Hi guys, welcome to our session. Thanks for getting up this early. I know 9 o'clock is really a hard time to get up for myself too. But thank you for all of you coming here today. My name is Max Knorr. I'm a developer evangelist at Microsoft Austria.
My name is Andreas Schabus. I'm the academic developer evangelist for Microsoft Austria.
One word first about our shirts. So I'm wearing shirt size X large.
Yeah, we decided that's the shorter explanation why I don't wear my shirt. So I don't want to give you that experience. So as you heard yesterday in the keynote about experiences.
But it's hanging before the desk here, in front of the desk here.
So let's start with our session about developing 2D games for Windows and for the Xbox 360. Well, what we are going to do in the next 70 minutes is we first would like to give you a brief overview about the XNA Game Studio Express. And then we will stay the majority of our time to developing a 2D game. Well, so if you have some basic knowledge with .NET and C#, I hope that we can have some fun together. Just for the interest of time, we would like to ask you to save your questions till the end. So we'll do a Q&A till the end, and we'll answer questions there. So what we're going to do, well, as I mentioned, we first will give a brief overview about the XNA Game Studio Express, how to get it and what you get. Then the majority of the time, actually Max is typing and will develop a game, XNA Canoid, for us. Then we will talk a little bit about what does it take to bring this application or bring games to the Xbox 360. Just because of time restrictions, we will not do a demo, but we will go through and we'll explain what you have to do to move there. Well, at the end, we will give a few suggestions how you can go forward if you got interested in XNA and you would like to start your own games. So what is the XNA Game Studio Express? Well, you can read it there, or a brief summary. It's a framework for developing applications. It's a framework for developing games based on .NET, and you can develop games for the Xbox and for Windows as well. And the good news is everything we use today is just downloadable for free from the internet. So you can just go to this URL and download all you need. Okay, if you have downloaded everything from there and you have installed it, what do you get with the XNA Game Studio Express? Well, if you are working on Windows, and actually the main development part is always running on Windows, you have the operating system, of course. On top of the operating system, we have the .NET framework, 2.0, 3.0, it doesn't really matter. On top of the .NET framework, you get the XNA framework. This is actually a set of additional libraries which gives you new functionalities which you can then use to develop your game. And then we need something to develop our games, which is, at the moment, if you're talking about the XNA version 1.5, it's Visual C# 2005 Express Edition. If you're going to move to the Xbox 360, we have the Xbox below, of course. Then we do have a .NET framework running on the Xbox, which is an adapted version of the .NET Compact framework. So we'll talk about a little bit later what does it mean for you to develop applications and where you have to take care about this. On top of the Compact framework, we do have the same XNA framework which we have on the Windows side. And of course, we're using the XNA Game Studio Express, which means the C# Express Edition. Okay, so before we really start, let's go into some basic concepts which we need for developing our application. Well, the first we talk about is the XNA application model. If you think about games, a game has other way how to deal with a game like with normal applications. So in a game, there is something running. There is continuously updating the screen. There are some movements, even if you don't do anything. So we have another application model there. And we start with probably the most basic class which you use, which is the main class. And guess what? This class is named game. So this is where everything starts in the XNA framework or in our game which we develop. And then we have 5 methods which are implemented in the game class, which are called by the XNA framework. As soon as we start up our game, we call the initialize method. There we do the initializations. The second method, and we will go through this and you will see what we do there as soon as we go to the demo. Then we call the method load graphics content, where we can load all our content which we are going to use in our application. And the next two methods are actually the main part where really the action is, where really something happens on the game. And this together is called the game loop. And there we have two methods, update and draw. The update method is used for updating the model, for doing something, calculate if we have some, whatever we have to check, if we have some collisions. All those things are done in the update method. And in the draw method, we just draw everything to the screen. And then, if we shut down our game, there's an unload graphics content method, where we unload all our resources to free every resources we have used in our applications. And then we need two more very important classes. One is the graphics device manager. Well, this is actually the interface between our game and the graphics adapter. As most games nowadays are very graphics intensive, so what we really like to do is we would really like to use the capabilities of the underlying graphics adapter. This is something where you as a developer who hasn't done something with games before may be surprised if you test on different machines. For example, we are using one application at the end, which runs perfectly on Max notebook, doesn't run on mine, simply because we have different graphic cards and mine has a much older graphics card. So even if you will see it's very easy to program, we still rely somehow on the underlying hardware. And then the second important class is the content manager. And if I talk about content, I talk about pictures, models, sound, whatever we would like to use in our games. And there are different formats, and this makes it quite complicated if you have this always back in your mind. And there the content manager is used. So the content manager just loads all these different contents, and then you can use it in a uniform way during your whole application. So Max, can you show us how this all fits together and how this looks like in code?
Yeah, sorry. Yeah, sure. But first of all, let me ask you a question. Who of you is developing compilers?
Who is actually developing applications at all?
Okay, well, okay. That's perfect.
Who would, let me ask two other questions. Who would like to develop a compiler? That's interesting. Even the people who develop compiler doesn't like to develop compiler. Who would like to develop a game? I mean, this is something which I find so extremely interesting because we as developers, we work with compilers nearly every day. However, nearly none of us would like to develop one. But even if we don't have something to do with games every day, it seems to be very compelling for developers to do games. And this is actually where XNA really comes into the game and help us to do so. Okay. Please show us the source.
Yeah, for this short demonstration, first of all, in the last row, are you able to see everything on the screen, or should I? Yeah, okay, perfectly. So here we are in the core part of our game, the game class. So, well, surprisingly, this class is called game, and what we do is inherit of this game class Andreas pointed out before. Like we make up a class called XNA Canoid game for right now. And here are the two core parts Andreas mentioned. The graphics device manager, which is referenced as a variable called graphics, and the content manager called content. So later on, we are using graphics and content, and you know graphics is the graphics device manager and content is the content manager. Perfectly. So what do we else have? We've got the initialize method here. Those methods are virtual or abstract methods by the game base class, and you, in your inherited game class, simply override them and do things in it. So you extend the basic game class by your custom functionality. And we've got initialize here, where you should initialize, or where we will initialize everything we need except graphic resources. So graphics resources like textures or something like this should be initialized within the next method here, load graphics content. Then we've got the two most important methods for the game, update here, and the next method, draw, below. So this is, as you see in the title, this is Visual C# 2005 Express Edition. So let's start up the game by clicking debug, start debugging. And yeah, let's see what the game does. Actually, it's very sophisticated. It's simply a blue screen. Well, we could develop a flight simulator or something on the basis of the blue screen, but we want to do a spaceship game later on. So first of all, let's change the background to something else, like space is mostly black, I guess. So what we do, as we want to draw something differently, we move into the draw method here. And within draw, we've got here our graphics device manager. And there we say graphics device, clear yourself with a color of cornflower blue. So what we're going to do is simply change cornflower blue to black here within the draw method. And every time the screen is redrawn now, it is redrawn with a black color. So, well, that's really easy, I think. But yeah, that was basically the first demo. Back to Andreas now. I know that wasn't very compelling, but we will move on with our game.
Yeah, thank you. And I agree, it's very hard to call this already a game. It's even for very limited fun. So, however, before we move on to our real game, let's give me a brief overview what you get in kind of functionality. What is in this XNA framework libraries available? Well, XNA actually doesn't bring a lot of new technologies, but it really does. It makes it easy to use the underlying technologies. So we're still using things like DirectX, Xinput, and so on. But if you have ever tried to write a game, you know that there is a lot of code necessary to just initialize everything, to initialize different hardwares, to use your own, or you develop your own game loop where you have to take care of the different speeds of the machines and so on. There is a lot of work to do. The main idea of the XNA framework, let's just make this easy. Let's make the first line of code you write should be the first line of code you write for your game, not the first line of code you write out of thousands for initializing your hardware. And if you have seen, even in the small demo which Max did, was that you see we have written one line of code and we at least have changed something which is responsive for our game. If you look at the very bottom, we see there are the platform classes. So there have some wrapper classes which wrap the underlying technology, like Direct3D, like Exact, and so on. Above this, we have this called core framework layer, where we have on one side classes for graphics, audio, input, as well as different helper classes, like math and storage. If you think about as soon as you move to 3D, what we're not going to do today, but there is a lot of calculations with metrics and so on, and there are a lot of helper classes, makes it easy for you to do these calculations. And then there is also a second class, which is the storage class, because if you think you will probably like to store things like configuration files, like high-file lists, all those things, which is actually pretty easy on a PC, because there we have a file system. But as soon as you move to the XNA, to the Xbox, then you have to think about how you can do it there, because there is no such a thing like a file system. On top of this, we have this extended framework, which consists of the application model, which we have already seen, and also the content pipeline. And then, really, on the highest level, we have to sing, and where the developers has to come in the game. There we have to use the code, and we have to provide the content which we are going to use in our game. We will talk about the two other boxes, the starter kits and the components, a little bit later. So now, let's really move to a real game, where we can do something. What we would like to do today is to develop XNA Canoid. So some of you may know this game, at least people are as old as myself, for example. But for the younger, the idea was just, we have a ship that you can move from left to right. We have a ball, which is flying around, and you have to hit all the boxes on the top. So this is the main idea of the game. And yeah, what we would like to do is we would like to develop is not just straightforward in a spaghetti-like code. We also would like to use a little bit object orientation. Not till the extreme, but we would like still to use it a little bit. So these are actually the main classes we are going to use, or which we are going to develop, which is the sprite class, which is the base class for our graphics, which is actually where we load an image, we can use the image, we can move it around somewhere on the screen, we can position it there, and we'll build up our scenes from multiple sprites. This is the functionality which we'll put in the sprite base class. And from there, we inherit three classes: the ship, the ball, and the stone. And Max is now going to show us how this all fits together to a game.
Okay, yeah, I will show if you turn on my screen.
Okay.
So here we are back again in the game class. We will do all of the development now within the game class and delegate different things to the sprite-based class or their inherited objects. So, but it's important that you keep the small tree with sprite and inherited ship, ball, and stone in mind when we're doing the development now. First of all, let's start with the ship, as this is one of the easiest things to do. What we do is within the game class, we declare a variable called underline ship, which is of type ship. The type ship actually is a class here which inherits of sprite. Sprite is also a custom class we did by ourselves, and what sprite does provide, we will see throughout the demonstration here. Then, okay, everyone knows this call. We initialize the new, we instantiate the new ship, and here above we also instantiate the graphics device manager as well as the content manager. And now, first of all, for a ship, we need something to look like a ship. We need the so-called texture. So when I started with, I'm originally a Windows Forms developer, and when I started developing games, I thought, oh, textures, this really sounds kind of high sophisticated, how to create a texture. The good point is a texture is simply a normal PNG file, for instance, and a PNG image. So what we are going to do now is we move into the load graphics content method, and there we will load the texture, the image file, to be drawn as the ship. So first of all, within the Solution Explorer, we need to add the PNG file to our project. We've got different project folders here, like the content folder and the textures subfolder, but you can choose them randomly as you like. This is a custom structure I made up by myself. And then let's add an existing item to our textures subfolder. And let's select the texture here. We need to change the extension below to PNG. And we've got the ship here, ship PNG. So ship PNG is now part of our project. When pressing F4, as normally we do to see the properties, we see the properties of the file here. And what we actually see is there is a property here called XNA framework content. If this property is set to true, this means that the content pipeline will manage this content part for you. So we've got a content importer and the content processor here, and those two parts are responsible for importing our PNG file and transferring it to an XNA compatible texture. So those are chosen automatically. You could also choose other importers, for instance, for fonts, or for audio files, or for pure XML content, but now we want to use the texture. You can even extend this content pipeline by custom importers and processors so that you can use custom file formats. Later on, we will show you a game where this is the case, where they use a custom importer. And important is this asset name here. The asset name is how we can get the file back out of the content pipeline by its asset name ship. Okay, so what we do is within load graphics content, let's, we could directly call now content manager.load, but we don't want to do this. We want to encapsulate this within the sprite class. So what we do is call underline ship dot load texture. The ship should load its own texture, and the only thing we pass to the ship is the content manager content, because the ship knows itself the best way how it looks like. So let's move into the load texture method by pressing F12. And within the load texture method, this is situated within the sprite base class, because we have textures at all of the free game objects, and we want to load the texture every time the same way. So what we do is within load texture, we say underline texture. This is a variable of type texture2d. Texture equals content manager content dot load. there, this is a generic method. There we can pass the type of object we want to load, like we want to load the sprite font to write something on the screen, or a 3D model or something like this. Right now we want to load a texture 2D object. And then we need to pass the asset name in the content pipeline. And as you remember, this is ship within textures within content. So this is the entire path we're going to specify now here for the loading. Let's say content / textures / ship. Okay. And afterwards, we need to, for positioning later on, we need to position the ship somehow. And to position the ship correctly, we need, of course, the size of the ship. And we can get the size out of the texture. So we say the width of the ship, or the sprite here, equals texture width, and the height equals texture height. Okay. So actually, we are having a problem now because we hard-coded the path of the texture into the sprite class, as a few of you already noticed. So all of the textures will look the same way. That's not good. So what we do is extract this here, and there is a property, an abstract property, which is called texture path. And this texture path here above is the declaration, is protected and abstract. So we can override it in all inherited classes. And this is what we will do. But the base load texture method will always load the overridden texture. So this is a kind of a trick to override the different textures in inherited classes. Let's move into the ship right now. And within ship, we've got the overridden texture path property here, which we will simply substitute by our hard-coded string before. So this is the texture which will be loaded for the ship, and other objects may have different textures. Perfectly. Back in the game class here. We've now loaded the texture of the ship. What else do we need? We need to position the ship and set the starting position of the ship. We could do this here directly in code, but again, let's call ship.resetPosition. And for the positioning we want to center, by the way, who of you knows Arcanoid? Wow. Okay, well, so you know where the ship stays in the beginning, so we need to center the ship on the screen. And to center something onto something, we need, of course, the size of the screen. And the size of the screen is encapsulated in an object of the XNA framework called viewport. So viewport is the area of the screen where the game runs in. And above, we've fetched the viewport of the graphics device by saying a local variable viewport equals graphics.graphicsDevice.viewport. And what we do is pass this screen area to the method resetPosition. Let's go F12 into resetPosition again. And there, what we do is center the ship on the screen. Andreas said that mathematics is important for 3D games, but it's also important for 2D games, unfortunately.
Yeah, but C# could do addition and subtractions by themselves, by itself. So.
Yeah, okay, but let's drag this in better because I'm really versed in mathematics. What we do is we've got a two-dimensional vector within our sprite base class. It is named position, and this is the position where the sprite currently resides. And we initialize this position with an x value here. Those of you who have worked with Visual Basic 3, 4, or 5 maybe know this centering logic. It's the same for a window or something like this. So x means centered on the x-axis of the screen. And the y-coordinate is 50 pixels below the bottom corner of the screen. So bottom corner and the ship is 50 pixels above the bottom corner.
Why 50 pixels?
I don't know. I tried it out with the game. It looks the best by 50 pixels.
I think that's important for some games. That's not always you have to do the correct way, even you don't have to think about the physical correct way, you just have to look good and feel good if you play it.
I think that's the most important
absolutely
part with games. But okay, so let's reset the position of this two-dimensional vector. And let's get back to the game class. So right now we initialized and loaded up the resources, set the initial position of the ship. But to see something on the screen, for instance, a drawing logic would be nice. So what we do is let's move into the draw method of the game. And there, you know the draw method already. We did the background stuff here. So what we do now is draw the sprite, the texture of the ship. And for this, we need an XNA framework object called sprite batch. So although sprite is a custom class made up by us, this is a common term for game development because the built-in class for drawing textures is called sprite batch. Batch equals new sprite batch for the current graphics device. Yeah, that's all. And who of you is familiar with the concept of double buffering? Most of them. So we're using the concept of double buffering now, saying batch.begin. And we need to specify a special mode here. It's called sprite blend mode, alpha blend. What this does is, as the PNG files have a transparency channel in it, we want XNA to take it into consideration. So it should use the alpha channels of the PNG files. And this is sprite blend mode.alpha blend. And afterwards, we call batch.end. So for those of you not familiar with double buffering, what happens is, after having called batch begin, we open up a kind of virtual canvas. Then in between begin and end, we draw on this virtual canvas. And afterwards, by calling sprite batch.end, we kind of drag over the virtual canvas onto the screen in one part. And so this is to prevent kind of flickering or something like this. So we pre-draw everything on a virtual canvas and then draw it on the screen in one pass. Yeah, and we can draw on, you know the story, we can draw on the batch directly now, but let's delegate this to the ship again, or to the base class sprite, and say ship.draw yourself, ship.draw on the sprite batch. And again, let's move into the ship. And there, so this is, again, not the ship, but the base class. This is the same for the ship, the ball, and the stone. And there, let's call batch.draw. Let's draw on the sprite batch with a specific texture. We loaded up the texture before. The next thing is the position. We loaded up the position before. This dot position. And the third thing is you can overlay a color, like a semi-transparent color to color the texture in some other color. Like if you have a blue texture, you can color it into red if you like to. But we don't want to use this. It's called tinting, by the way, but we don't want to use this. So we specify the color variable, which is white by default. But later on, for the stones, we will use the tinting. Okay, that's all we need to do to draw the thing. And okay, we haven't seen the game for a long time, so let's start it now. And it's working. Andreas, should we?
It would be nice if you put me somehow in control. By the way, we use a normal Xbox controller for this.
Yeah, you can. There is an Xbox controller for a USB port, and we are using this device now. So you can test even your gamepad controls on the PC and later on only deploy it to the Xbox.
But nothing really happens.
Yeah, well, I'm not really surprised because we haven't reacted to the user input right now.
Okay, so we may do this.
Yeah, we did a nice wallpaper right now, not more, but for a game it would maybe be a good start to react to the user input. I'm not sure. So let's do this. And as Andreas said before, everything for updating the model of the game is done within the update method. So this is the point where we are going to now update. And there is already one built-in statement out of the project, because we simply, when creating a new project, there is already this call in it to allow to quit the game. But we don't need this call. No, we don't want to quit the game ever. So let's fetch the state of the gamepad. And for this, we've got a class called gamepad state, which is the current state of the gamepad. State equals gamepad dot get state. So this is pretty self-describing. And now, as there can be multiple players, we can specify which player we want to query. And we want to query the first player, of course, right now. And then we can, by saying state dot, we can use different parts of the controller. So we have buttons there, we've got a digital pad there, we've got thumbsticks, and we've got the triggers. What we want to do right now is, on the ship class, we've got a property called speed. This is simply a value holding property of type float. This does nothing else but store a float property, and we assign this speed to state dot thumbsticks dot left dot x. So this is the x-axis of the left thumbstick, and there are two on the gamepad. And then we want the ship to update itself and to react on the speed, so it should move forward and move on to the left or right direction. For this, we need to pass the game time, and maybe we could need the viewport in as well. What is the game time, by the way? We will see. Let's move into the update method. And there, this is now not in the sprite, but in the ship inherited class, because the update is differently for all of the objects. And what the ship does when updating is, it manipulates its position, the x-axis, and adds the speed to it. This dot speed. But we also need to take different machine speeds into consideration. I would say that Andreas' Toshiba notebook is slower than an Xbox 360. Maybe.
It is.
It is certainly.
Definitely.
So maybe the game would be quite okay on his Toshiba notebook, but would be really fast on an Xbox 360. So you couldn't even play it because of the speed. So what we can do is take the real time it took for the game to do something, like seconds or milliseconds, into consideration. And this is what the game time object is for. Let's say we multiply the speed with the game time, elapsed game time. So these are the seconds or milliseconds since the last call of update, since the last update cycle. So we know how fast the game is running because of how fast the different update methods are called in the sequence. And we use the total milliseconds there. And to slow down a bit the ship, we multiply it by a half. So always watch out. You need to cast total milliseconds to float. Please remember please tell me if I forget this, because this is a common problem.
I mean, by the way, what we do here is there is also you can also say to the XNA framework, please take care that you call my update and my draw methods to continuous time, so that you know since the last call of your method there are already 50 milliseconds ahead, so which both of your methods get called every 50 milliseconds. We turn it off because it gives a slight better graphic experience, and then we have to think about later in the game that we have to add this functionality.
I'm sure you know the term frame rate, and frame rate means FPS. FPS means how often the update is called in the sequence, so or draw is called. And XNA by default has this fixed step mode. We can dig into it. It's the fixed step mode. You can change it here. Game.isFixedStep mode, and this means we have a fixed frame rate. The draw and update are called in a well-defined manner, but we don't want to use this right now. We want to use the full frame rate, so we turned it off, and now we need to take the game time into account. Okay, and after, let's move back to update again. Update. After having updated the ship, I would say we now set the speed of the ship to the thumbsticks of the gamepad, so we react to Andreas now. And we set the position of the ship. So Andreas, you're my test player today. Hey, what have you done with the ship, to the ship?
Nothing. I just lost in space somewhere.
Okay, so yeah, maybe that's a problem when developing spaceship games. We should kind of build a box around the ship to disallow the ship to move out into space. You could wait for hours. If you get asleep on the gamepad, then the ship is somewhere out and you can wait for hours to move it back in again. So that's not very compelling. We should capture it within our screen. And for this, we use collision detection. So collision detection is what you use in a game to check for if one object collides with another, bang, and then we want to do something, if they touch each other. And this is what we want to do now, check for the collision with the ship and the both borders of the screen. So for this, we've got a little helper method here called this.checkCollisions. So after having updated the ship and moved the ship to its new position regarding the speed, what we want to do now is check if the ship now is out of the screen, if it has a collision with the borders of the screen. And this is what we do. Check for collisions. So unfortunately, this method is empty because we have to implement it by ourselves, but it's not that hard. Let me see, is there a code snippet for it? No, there isn't, but it's pretty easy. Some mathematics again. Oh, I love this. If ship dot position dot x is less than viewport x, well, that's pretty easy. Viewport x is the left border of the screen. Ship position x is the left border of the ship. If the left border is behind the left border of the screen, then there's something wrong. Let's set the ship dot position x to viewport x. And for the right border, else if ship dot position x plus ship dot width is bigger than viewport x plus viewport width. That's a bit more complicated, but it's the same statement for the right border to detect collision of the right border of the ship with the right border of the screen. Bang. Then what we do is ship.position x equals viewport x plus viewport width, the right border of the screen, minus ship.width. And now we should have encaptured Andreas within our screen. Are you cheating?
No.
Okay.
It works.
Okay. So now we did some basic collision detection there. So collision detection is purely about mathematics, but we will show a better option later on to do this. Well, the game is, you're my testing player today. What's your experience of the game?
It's still somehow limited fun. At least even if something's moving, it's not the wallpaper anymore. But
now
yeah.
I'm really dissatisfied by your feedback. But okay, nevertheless, yeah, we should improve it a bit. And what we do right now is drag in the ball. And now we want to show you the advantage of our object-oriented model. The ball is, as well as the ship, a texture. So we can now reuse the common methods. Ball, of course, we need to instantiate the ball as well. But now, let's move into load graphics content again. So within load graphics content, we of course need to load the texture of the ball as well. Content. But this time, we've got the method finished. It's ready. What the only thing we need to change is within ball. Ball also inherits of sprite. We need to override a different texture path property. So this time we will draw the ball differently than the ship. Fine. Then we also need to set an initial position for the ball. Ball.center on ship, because the initial position of the ball is centered on the ship. Let's pass the ship there. And center on ship is already pre-implemented. It's the same centering logic again. I don't want you to get boring of this centering logic here. What we also do is say the ship is now, the ball is now docked on the ship. So the ball will stick with the ship. And if the ship moves around, the ball will as well. This is simply a Boolean property. We will use this later. So after having loaded the graphics content, you know this already, what we do is drawing. Okay. Simply put in ball.draw batch. The important thing is if you want to have different set orders, for instance, if now it's not the case, but if the ball needs to be in front of the ship, so if you are the users on the PC screen and I am the PC screen or the Xbox screen, then the ball needs to be in front and behind this, the ship. Then you need to take this into account in your drawing method. So the set order is ship will be drawn first, and then ball will be drawn. So ball will always be in front of the ship if they overlap. Okay, this is important. And yeah, but that's all we need to do, the same sprite drawing logic here. Some differences are there in update, of course. What we do is fill in ball.update, passing game time again, passing viewport again, this time also the ship. We need the ship as well. Let's move into update of ball. And there, we need to react on different situations. Either is the ship docked, is the ball docked on the ship, then it should stick with the ship. So let's simply recall center on ship again. Not app to main, ship, okay. And send the ball with the ship, on the ship, as long as the ball is docked on the ship. This is the initial state, so it will always stay with the ship. And if we are not docked on the ship, then let's again move the ball around by adding the position, by adding the speed to the current position with the total milliseconds as well. Okay, the same thing again. Oh, not again. Okay. So, but how do we start off the ball? We are always docked with the ship, so we need some check here as well. Let's fill in something to react on the gamepad state again. Gamepad state. So which control do we want? Let's take the buttons, for instance. The buttons dot, there are different kind of buttons, an A button, back button, left shoulder, right shoulder. I wouldn't even find them on the gamepad, so let's use the A button and say button state of it should be pressed. So if the A button is pressed, then, well, let's start off the ball, ball.start. And what this does is, here in the ball class now, set the speed of it to a new two-dimensional vector again, minus a quarter float, and setting docked on ship to false. Well, pretty easy. So we do the whole movement of the game objects by adding two-dimensional vectors. So we don't need to calculate x and y positions by ourselves, but we use the vectors here. Okay. Should be okay. So let's start up the game. It sticks with the ship, as the ball, as long as we are docked on the ship. Now, start off the ball. And of course, it's the same problem with collision detection again, but this time we'll simply drag it in. We don't want to bother you. This check collisions, drag in the new block. By the way, you can download the whole source code of from our blocks.
Yep.
So you can get the game in source and look around and see if you're really interested in the collision detection details, the dirty details. You can really dig into it. Let's check collisions of ball with the border. Okay, drag this in.
At the end, it's actually the same thing we do here. It's just that you have to calculate on the three sides.
Yeah.
Instead of on the two, right and left, you also have to take into account
the only difference is we reflect the ball. If I'm now the wall and there's some ball coming coming into my direction, if it reaches me, what we do, so the ball is coming from below. If it reaches me,
I could throw something at
no, please, no. You could be the ball maybe, but if it reaches me, then we change the y speed vector or the x speed vector. So what we do is the ball moves back into the other direction. It bounces off me or the wall, and this is what this cos speed multiplied by -1 does. So it multiplies the speed vector by -1, it reverses the direction. And if we collide with the bottom corner of the screen, what we do is here, reset to the initial position and decrease the amount of lives. Okay, pretty easy. You know this collision detection already, but we have another collision detection in the game as well. We've got to detect collisions of the ball and the ship if the ball collides with the ship. And this time we thought of a different concept, as both of them are sprites, because ball is a sprite and ship, they both inherit of sprite-based class. So what we did now is on sprite-based class, a method for detecting collisions of two sprites, because later on we have also the blocks, and we also need to check for collisions with the blocks. So let's call if ship dot, and now our custom method here is collision with ball. That's a lot easier than doing the high sophisticated mathematics stuff. And if ship is collision with ball, then let's also reverse the speed of the ball. It's y as far as I know. Okay. So an is collision is a base class method within sprite, and what we do here is simply intersect two rectangles. I know ball is not really a rectangle, but yeah, let's work with this right now. So we make up two rectangles for each sprite. We could do something better by using the real texture and taking the alpha channels into account, but we don't do this here in this simple demo. We simply make up two rectangles of the position and the width and the height, and then we intersect those two rectangles, and if they overlap somehow, intersect is a method of the XNA framework, so we don't need to write this by ourselves, and if they intersect, then boom, a collision happened, and we know we need to do something. So, okay, our final version for now. Ooh, pretty exciting.
Yeah, but at least now something's going on.
Yeah, okay.
By the way, just by my own experience, I can warn you, because
there was some problem in it, huh?
I haven't seen something.
Can you? Hey, what are you doing?
I play the game as I get it. You
Okay.
wrote the game, I just use it.
Okay. So there is some cheat in it. I definitely also know where the cheat is, but I wanted to let Andreas have some fun here. Okay, one cheat isn't intended. Yeah, here we are. You've lost now.
Yep.
Yeah, the problem is we start off the ball each time, and we don't check if the ball has already started off. So you can start off the ball again in mid-air, and this is not very good. But it's every game needs every serious game needs a cheat code. So let's leave this in it for now. And
by the way, let me warn you, when we have developed these games, and because we're now working in a completely different area, and I have developed a piece of this, and we're sitting in my working room together with the bed and testing, and we're trying out the collision detection and so on. It was about, well, after hours for developers, means about 3 a.m. in the morning. And my girlfriend passes by and says, "Oh, what the hell are you doing?" They say, "Well, honey, I have to do some work. You have to prepare your spouses or girlfriends or boyfriends up front so that someday now work looks different for you than it has ever done before."
At least if you are a game developer. So, well, for now, we could either, it's your choice, we could either continue watching Andreas playing the game for the end of the session, or we could do something more.
could also show just the blocks.
Yeah, what do you want to do?
Yeah, I think that the majority was for probably more.
Okay.
If it's pretty exciting.
Okay, then we skip your opinion and let's move to the next topic. Let's show you how to improve the game even more, not by the blocks. The blocks are the same as the ball and the ship. You can look later on into the source code. They are sprites again, and you know the whole stuff. So now let's move into some advanced topic.
Yep.
Andreas, could you tell us something about it?
Yep, I can do. Actually, this is the good thing as we have started the object-oriented approach, so that we now, the stone from the point of view of the developer is nothing more than a not moving ball or a not moving ship, which you just position, and the only difference is if it gets hit by the ball, then you just have to remove it. So it's pretty easy now. So even if from the beginning it doesn't look that easy to go this way, it still pays off later, and it makes it much easier to go further and to do more sophisticated things. So, however, even if I think that's really a nice game, especially if you imagine the blocks in it, and yesterday we heard a lot about experience, and what we really would like to do to move it a little bit forward and give you a more professional look and feel. If you think about the professional games, you have a startup screen, and you may have a game over screen at the end. There is, of course, typically some high score lists, whatever you do. And what we would like to do is we would like to now implement those for our games too and show you how you can do this actually quite easily, I think. There's only a few changes which we have to do. If you think back about, I don't know, 30 minutes or so, when you had this slide with the functionality which you got by the XNA framework, there was this blue box on the right corner which has stated component. And actually, the idea of components is that you can just take existing functionality, plug it in your application, and then you can use it. And it's independent if you have written the component by yourself, or you just take a third-party component, take a component from a friend, whatever. We know this concept by, if you have developed this Visual Basic, we had the Visual Basic controls. Then it were moved over to the OCX controls. And we have the same idea implemented in the XNA framework. It's still called component, but it's called game component. And the game component is actually a piece which you can plug in. And then I mentioned the real important methods for a game is the update method and the draw method. And so you can just use this, and then you have to call the update and draw method on everything in your game by yourself, like we have done for the ball and for the ship and so on. But if you use the game components, you have a base class which actually implements two important interfaces. Of course, iDisposable is also important, but that's more or less a standard interface. It implements iGame component, and iGame component provides this functionality that as soon as you have included this component in your game, the XNA framework knows, okay, there is a component, and I have to call the update and the update method, or I have to call actually methods on the component also, so they don't have to forward and do this gluing code by yourself that you have to think about what have I included at the moment in my game, where do I have to forward those codes. And there are two classes. One is the game component, which implements the iUpdateTable interface, which means there is an update method, and the update method is called by the XNA framework. There is also a second component class, which is drawable game component. And guess what? There is not only the update method called, but also the draw method. So how are we going to use those concepts to improve our application, to improve the look and feel of our game? Oh, it's the application, actually. Pardon? So I really smoothed into this game development. It's just a normal application, just it makes more fun to test it.
Game is application plus fun, maybe.
Yeah, maybe something like this. Okay. What we do now is that we have something developed like it's a game screen manager. If you think, I mentioned that we will have different screens, but I would like to do all the development by myself, that I have to ask which screen is visible at the moment, which screen I have to call, and so on. So what we have done is a game screen manager, which is actually a component, a game component. And now all calls, which normally goes to the game class, which are the update and the draw method, are forwarded to this game screen manager. Okay, well, the game screen manager has a screen collection. And in the screen collection, we have included all the screens we're going to use. So the game screen manager knows all the screens which are available for the game. And he also knows, because we tell him, which of these screens is visible at the moment. So let's see if we say, okay, we would like to have a start screen on the beginning. We just said, okay, the start screen is visible now. And then the game screen manager says, okay, I have to forward my draw and update methods to this start screen. Then we do something on the start screen and we come to the play screen. Then it's forwarding all those things to the play screen. However, there may be a situation where we would like to have more than one screen visible at the same time. Think, for example, at the end of the game, we would like to show a game over message. And we could do this very easily, but just have two screens, the play screen, because we would like to see our player, what he has done wrong or where the status currently is. And we just overlay this game screen or display screen by the game over screen. So there, the only thing we have to do afterwards is to tell the game screen manager and say, okay, please show those two screens together. And we also give him the order that the one is behind and the other is in front. And then, of course, we also will have a high score screen. So this is the way how we will implement those things. By the way, the game screen manager is something which we have developed by ourselves. But you can also, as Max already mentioned, if you download the source code, you can also take a look into it. We'll go a little bit through, but basically it's more or less just forwarding method calls to the correct thing. So Max, are you going to show us how we can improve our game?
Okay, so we are now back in our game class again, but everything changed right now. We took out all the things out of the game, the playing logic we did before, and also now there are the blocks also in it. And all this playing stuff is now in a separate class. And the separate class is here in the subfolder game screens. It's called play screen. So this play screen is what formerly has been the game. It's now encapsulated in a separate game screen. But we don't care because the game screen has all the same methods as well. It also has draw and update and so on. So it's simply cut and paste here, refactoring. But the advantage is now we've got here in the game itself the game screen manager, the master of the game. It will do all the logic for the game. And what we do is instantiate the game screen manager and add it to the this.components collection. So who of you has been or is a Windows Forms or WPF developer? Okay. Half, let's say. So it's, but I'm sure there are the same concepts in ASP.NET as well. So you add the game screen manager to the components collection here, and this automatically causes things to be happening on it. So it's like controls in Windows Forms or in ASP.NET. But yeah, we add it to the components collection, the game screen manager, and if we now, well, okay, let's move a bit down. If we now look into our game, there is only one method here, initialize. So we don't have the update and draw methods again. This is automatically done by the game components. And within initialize, what we do is say manager.loadScreen, passing it a new screen. So this is the screen which should be shown at the start of the game, the play screen. So, well, let's simply start up the game. And let's debug through our game. Because with XNA Game Studio Express, of course, you can debug through the game, even on the Xbox, but we will come to this later on. So here we've got the call manager.loadScreen. Let's debug into this. In the game screen manager now, we've got two collections of screens. And those two collections are, first of all, the currently visible screens, and the other thing are proposed screens. So it's like a bit like the double buffering on another level. We've got upcoming screens, and we've got currently showing screens. And now what we do is clear the upcoming screen collection and add this new screen, the play screen, to the proposed upcoming screens, okay? On the new loaded screen, we also set the parent screen manager so that we can later on access the screen manager out of the game screen. and move to another screen, for instance. Then we forward all the calls to the screen, like here we forward initialize, for instance. Okay, then we are in initialize, and again, okay, we call initialize on all available screens, but no screens are right now available. So, because we are only added a screen to the proposed screens. But okay, that's a detail. Let's remove this breakpoint here. What's interesting now, we are in the load graphics content, and there again, of the game screen manager. So this is called automatically because of the game component thing. The load graphics content of the game screen manager is loaded, called automatically by the game class. And there we forward all the things to the different screens. Okay. So now we loaded up the graphics resources of the play screen. And now we're in the input loop. In the input loop, what we do is, first of all, well, forward input, forward up. Oh, sorry, did I say in the input loop? No, we are in the game loop, of course. Yeah, we're in the game loop, and now we're in update. And with an update, what we do is forward the update calls to all of the screens. So each screen of the currently showing screens, which is none right now, should update. Okay. And then what we do is move the proposed screens to the current screens. So we clear the current screens and then move all of the proposed upcoming screens onto the real screen here. Okay, perfect. Let's move on. And then we are in draw this time. In draw, we forward draw to all of the screens. Okay. Then we are again, because game loop, we are again in update, and there we call update on all of the screens, and we would change the screens if there were any changes, but there are no changes right now. Okay. So it's simply a forwarding of update and draw and load graphics components to all of the screens. Now Andreas also can play the game. You see there are stones on top. We also added this font. If you're interested in how to do this font, just download the source code later on. And we also added keyboard input, so we can do a multiplayer game, Andreas and I, but only on one screen. And here is the second overlay screen with the game over. And afterwards, there would be another screen as well. But let's skip this here. We want to add a new screen. In front of the play screen, there should also be a start screen shown. So for this, what we do, within game initialize, we say now at the beginning of the game, let's load another screen, not the play screen, but a new screen called start screen. And this new start screen, if we F12 if we press F12 and look into it, it's also inherited by game screen. And it has also the different methods like initialize. We also have some fading logic in it so that you can fade in the screens. This is simply done by drawing a black rectangle which changes its transparency from 0% to 100% transparency. So it's at the beginning it's non-transparent, and at the end it's totally transparent. And we overlay this. This is how fading works. And yeah, but these are details. We load up all the resources and then we draw things. Okay, well, quite okay for a start screen. We draw some textures. And what we want to do now is, if the start screen has been displayed, we want to fetch some input. If Andreas presses the A button, then we want to move to the next screen. And another concept which we did in this version is to separate the update and the handle of input. So in one method, in update, we change the objects, the positions, and something like this. And within handle input, we react to the user input. Handle input, this is all made up by ourselves. So this is nothing from XNA. That's kind of an architecture decision for your game to separate those two calls. And out of update, we simply call handle input. But the advantage is we've got a special argument here called the input state. And this is a wrapper class which abstracts keyboard and gamepad input. How does this work? We want to move on to the next screen if either the Enter key is pressed or the A button on the gamepad is pressed. So we've abstracted this if input state dot next key is pressed. So this is a Boolean. Then let's say this dot screen manager, the parent screen manager of the screen, dot load screen, and we want to load the new play screen again. Okay. Quite easy, but what does the state.next key does? For all of the keys we want to use throughout our application, with an input state, we declare kind of properties. Like here in the input state, we've got a Boolean property called next key. And this property queries in one call, first of all, the keyboard for the Enter key, and then the gamepad state for the A button. Also some logic to prevent that you can hold the A button, but yeah, okay. So we say either Enter key or A button pressed. And throughout our application, we don't need to care of gamepad or keyboard. We simply query input state.next key. And we can easily change this next key if we want to, because this is in one place here. Okay. So we query for the next key in the start screen, and if the next key has been pressed, then we load up the new screen. So let's start the game again. So there is some breakpoint. Here we are. Here is the play screen. And if one life is lost, if Andreas lets drop the ball, what we do is load the next screen. Don't let drop the ball, because we also have some sound here. Oh, it's too late. We need to restart. This is another, okay. Okay, maybe some composer could do some better sounds, but the third thing is there is this high score screen, which is also another screen like the start screen, but on this high score screen, we query, we work together with the isolated storage, with the storage of the Xbox or the PC, and we store our high score list on the, no, disk is maybe too much, on the memory. Let's say memory. It depends on whether it's Xbox or something else. So if you're interested in isolated storage, how this works, simply open up the high score screen there. You can see who's the guy playing this game often. No, Andy is a hard-coded name for the high score list. So. Yeah, that's the game basically. Audio effects are there in it as well. Same, you can look them up in the source code. So back to Andreas.
Okay, thank you. And I now think we now have really a game where we can browse off, which you can show to other people, because you have all the things which you actually expect from a real game. So, but let's move a little bit further. First, one thing we mentioned a couple of times, very often you start just with the spaghetti code, but even in game development, it pays off if you use object-oriented methodologies. So what we have done, we have put the drawing and update methods in the game objects, which we call, we have base classes for common functionality, but we also use the game components. By the way, there will be an extension for game components with the next version of the XNA framework 2.0, which should actually be released somewhere in the near future. We have separated our screens so that we don't mix all these things together and have all the code inside the cell.
Somewhere in the near future is very nice. So that's, I don't know, somewhere in the near future. But actually...
that's the exactest we can say. I mean...
Yeah, okay. But I've heard that you can then nest game components. So we could then make the game screen manager one game component and make each screen another game component and simply add the screens to the components collection of the game screen manager component. Yeah, okay.
Okay. But we also mentioned at the beginning that we can develop games for the Xbox. And just briefly, we'll go through how you can do this. Well, actually, if you install the XNA Game Studio Express, you do get a set of templates for Xbox 360 games. And you don't have to worry too much. It's because sometimes it's okay, if I now would like to transfer this game to the Xbox, I have to start all over. Not really. The main reason why we have to have two projects in parallel is mainly because of, in one case, we use the .NET framework, in the other we use the .NET Compact framework, and the Express version of the IDE is not really able to handle this in a good manner, so that it knows, okay, if you start it up on the Windows platform, you use one version of a specific DLL. If you start it up somewhere else, so this is the use another. So this is mainly the reason why you have to do two projects, but you can use the same source code as long as you stick to the XNA functionality. If you would like to use something from the other parts of the .NET framework, think about all the functionalities which you get with .NET 2.0. So there you have to be a little bit careful. There are things in .NET 2.0 or 3.0 which are not available on the Compact framework. But if you take care about this, it's don't have to change the sources. If you press F5, you deploy the game automatically to the console, and then you can do remote debugging. Actually, the development experience is very similar to what you get if you develop for mobile devices. So you just have your development machine and the Xbox on the same plan, and then you just deploy it to the console. It starts up on the Xbox, and you can do remote debugging and all these things which you would like to do for development. What do you actually need if you would like to do this? Well, of course, you need a machine where you're developing, and you need an Xbox. The important thing, this is a normal retail Xbox. There's nothing special. You don't need a development Xbox. You don't need an Xbox SDK. You just take a normal retail Xbox, and you need an Xbox Live account. So if you have all these three pieces together, there are a couple of configurations you have to do. Well, first you have to go to Xbox Live. Apologize, but as I'm a native German speaker, I have a German version of the Xbox Live, therefore I have the German screenshots. However, it's not a big difference in other languages. So there, if you go to games, you have there this tab below, demos and more, and there you can click and select XNA games. So you would like to play on your Xbox XNA games. So if you're there, we now have to tell our development engine, actually the Visual Studio, okay, I would like to use an Xbox for running. There we give in the options dialog, as soon as you have installed XNA Game Studio Express, there is a new option which is called Xbox, and you can add additional Xboxes. There you give it a name which you can choose randomly, and you have to put in a connection key, which actually is the address, if you like, for the real Xbox. I'll tell you in a minute how do you get this connection key. What you have to do afterwards is that you say, here you see in the options dialog, where you see now we have connected to this Xbox. What you have to do now is you have to go to your Xbox. You have already started this XNA launcher. And now you have to say connect to computer, so that the Xbox knows, okay, let's wait till a computer would like to connect to me. I mentioned this connection string. You get the connection string if you click and select the settings, and then you get the connection string for this specific Xbox. The reason is you could have multiple Xboxes at home, and so that the IDE knows exactly which one you're talking about if you would like to play on the Xbox, so they can select this. Okay, so now, as soon as you say you would like to do something, you would like to connect to PC, the Xbox just takes a round trip to Xbox Live, doing some security checks, and then it waits. You have this nice blue screen. In this case, it's a good thing, because you know my Xbox is waiting for something. And what we do now, we have developed our application. We have used the templates for Xbox games. And now, as soon as we press F5, the application is compiled and automatically deployed to the Xbox. The game starts up on the Xbox side, and you can debug and do remote debugging and all these things around. So this is actually pretty easy. It's easier than handling the clicker. Okay, What may be the next steps if you really got you excited about doing game development? Well, I think there are two ways where you can move on from here. One is you could extend the XNA Canoid game. So you can download the source, you can put in special stones, for example. Most of you know the game anyway, that you know there were versions. If you hit a specific box, you get a wider ship, you get multiple balls, whatever you like. You can go to multiple levels and so on. A second thing which we provide actually during the website is starter kits. A starter kit is actually a full-blown game, which gives you a lot of functionality. You can download it, you can compile it, you get all the sources, all the contents, everything you need to build your game. And there you can either play the game, which gives you a lot of fun. There is a racing game, there is a space game, there are different kinds of games there. But you can also take this and take a look at it and say, okay, how do you have to implement those things? So actually, we did just for a second, because we run out of time.
Yeah, but we want to show this really to you, because this is the XNA racing game. So we really have all of it as a source code. Please keep this in mind as you see the game later on. And there are some custom content processors in it, because they really have rich content, as you will see. Let's start up the game. Oh, we've got sound there as well. Start here.
The main reason why we also like to show is that you see how far you can go with XNA if you know what you do. So it's also probably nice to just download this, compile it, and so on. So I think that really, you see, we have shown you the beginning of the adventure, not the end of what you can do with XNA.
But I'm sure it took them more than 70 minutes to build this. But
so we have to care about our time anyway.
Yeah, but the nice thing is, if you're interested in how they built the game, or even in extending the game, you can download this starter kit and really dig into the source code. I mean, it's not that easy to read. There is a book also on the source code, but yeah, feel free to dig into it. And
yeah, in interest of time, we move into Q&A outside of the room. If you got really interested in doing games with XNA, we provided some resources where you get additional information. You get the source code mainly at the moment at Max blog. And well, don't forget, if you really liked this talk, please fill out an evaluation. You can also win something. If you don't like it that much, see us afterwards and let's discuss what we can add to make it more fun for you to use XNA.
Okay, and if you have any questions, we will stay in front of the desk and then later on move out of the room as they kick us out. So feel free to ask.
Okay, thank you and have a nice decade.
Thanks.